Okay, let's take a look at Module 11 from the challenge problems. And here I really want you to pay attention to my notation here, that the hand portion is important, the five-step process that you're really aware of, that really kind of outlines all the things we need to check for in a hypothesis test. So first, in this first situation, we're going to recall that when we're writing the null and alternative, right, hypotheses, they're based off of the sample, right, data when we actually run the test, right? The sample data is kind of like the evidence that we have, and then the hypotheses are what we're using this evidence to test to see, right? And so we have a standard process of the null hypothesis always containing an equal symbol, meaning that we're stating that it equals this, or some value, some proportion, depending upon if it's quantitative or qualitative. And so in this case, it's a little bit easy to do because these parameters are given to you, right? We're stating what we think the population parameter is. In this case, again, this is a quantitative variable versus a categorical, right? And when you make your statement, again, you got to remember these are parameter values, what we think the population is, and then later on we collect sample data and test to see if that sample, right, what's the likelihood that that sample comes from a population with a parameter like this. So in these values here, we have to pick the right inequality symbols for the alternative. You'll see H1 or HA, right? So we're saying that it is equal to 66, so the alternative would be not equals to, right? And in this case, test if the percentage of students who took it is more than, so that becomes the alternative. And the null hypothesis always equals, even though technically it's the alternative would be equal to or less than, right? But for our process, we state equals within that. And this would then be a two-sided test, and this would be a one-sided test, a right-sided, right tail, because of the greater than. And again, what we're testing is the likelihood, right, that the sample data that we get comes from a population that has these parameters, right, that says that the population is 75%, right, for first-time brides. And so then we go through the 5 steps, write the null and alternative, HA or H1, H0, right? What test? Identify the test you're using, Z, right? Proportion, depends on the sample data. The sample data is a proportion. And then you check to see your conditions. Do you meet your conditions so that we can use these methods and then feel confident in our conclusions? And so this first time with 1 samples, we're doing it by hand here, and you can see the calculations. And then once you get a value, once you get your test statistic, this is how far the sample data is from the population, right, or a parameter, what we're saying here. And then we use a z-score, and that's what the z-statistic is. So that's it, the sample data. We're checking to see how far it is from the population claims, or our parameters here. And then we calculate, and that's the value. Then we're checking to see how far from it. And then we use the normal calculator to calculate. And now notice, this is a two-tailed test. So when we calculate it by hand here, we get 0.177, but we have to double that because it's a two-tailed test. We're saying that it could be greater than this or less than this, and that's the idea. Not equals means that you're either greater than or you're less than, and so you have to actually account for both. And then make sure you know how to state your conclusion, right? Make your decision, fail to reject. In this case, because our p-value is greater than the alpha, and the alpha is determined ahead of time. That's based on, again, how confident you want to be with our conclusions. And that's why it varies. It depends. Some people are 10% willing to be wrong 10% of the time, 5%, 1%. And that's what allows us to make those decisions here. And again, notice this is a one-sided test, greater than. And then here's your sample data. And notice in the test statistic, again, we're measuring how far is the sample data from the population parameter that was stated. That's the important process. Just so really think about what we're doing when we're running these tests. And once we determine how far it is in terms of standard errors, right? Because it is a sampling distribution, you can see there's your standard error, right? You end up at 2.62, and that's a t-score in this case, similar to a z. And this is, you calculate your p-value, and then this is your p-value because it's a one-sided test. And since it's less than alpha, we reject the null hypothesis, and so then we have sufficient evidence, right, to conclude that. And so I want to make sure you're clear with that. Now, when we do these tests, what our alpha is and what level of confidence, right, is based off of, again, this idea that when we do collect this data, we're not 100% sure, right, of our conclusions, right? There is some level of certainty because it's sample data. That doesn't necessarily mean, again, that it even based on our conclusions that we're going to have 100% certainty, right? Because it is just sample data. And all the sample data gives us evidence that something's going on. And so we have this diagram, right, that says these are errors here within it. We have two types there. Think about when you have, when you're making this decision, right? We've talked about type 1 and type 2 errors. And again, on this problem, I want you to think about it specifically with respect to this problem, right, that we have here. Right, with what we have here. A type 1 error is when you reject the null hypothesis when it's true. So remember, we have our null hypothesis. We're saying the proportion equals 4%. If we reject that when it's true, that's a type 1 error. Type 2 error is when we fail to reject the null hypothesis, right? When the null hypothesis is actually false, right? So we say, no, we believe it's 0.04 when it really isn't, right? And that's a type 2 error. And so the wording here is within context to this problem here. Now, again, sometimes remember, we don't know what the answer is because we're trying to talk about we're talking about the population, which the only way we know about the population is if we're actually able to ask everyone from the population. And so that's important there that we can. So we're using sample data, and the sample data is giving us evidence, right, and how strong it is. And that's where the p-value comes from, right? But doesn't mean, right, we're 100% sure. So just keep that in mind. And then number 5 was kind of walking through some key terms within the context of a study, right? Observational units. What is the variable? Thinking about, again, what type of variable it is. So make sure you go through these here. Let me see if there's something. Again, really remember in this situation, we're using sample data to try to make some conclusion about inference, right? Inferential statistics about the population. And that's an important piece here. And so you should be able to look at a context, a situation, and then really think about it. Because this goes beyond just memorizing what to do with the null and alternative, right? We have to start thinking about where we are with what does this mean, right? So again, these are within the context of this here. I didn't challenge you to think about type 1, type 2 errors, but that's a good thing to think about also within this context, right?